Good afternoon to our lecturer and all my group mates. Today, we would like to present our algebra project. So we are from group 10, and my name is Vimalnath, son of Murugia. My matrix number is CI220020, and my group mates will introduce themselves.
Hello, my name is Kobunto, matrix number AI220278.
Hello, my name is Sunny Junleong, matrix number AI220169.
Hello, my name is Tan Zihong. My matrix number is CI220014.
Hi, my name is Sharini, daughter of Arumugam, CI220001.
Hello, my name is Tan Hui. My number is AI220256.
So let's begin with our introduction. The trigger we chose for our project is business. So basically, business is a practice of making one's living or making money by producing or buying and selling products, such as goods and services. It is also any activity or enterprise entered into for profit. Based on this trigger, our group has created a project using problems of real applications and the methods to solve it using our knowledge in algebra. We have created four mathematical problems and showed the mathematical solution to solve these problems using metrics and linear programming. So let's start with part A.
Okay, question 1. I will read out the question for a while. Nav Company records sales of the following three products of clothes: name, ordered, Mega X, and Synth. I will call this as a S product lah, with different profit margins during the 3-year period 2020, 2021, and 2022. In 2020, the number of sales of product ordered and Mega X and S product are 9,000 and 10,000 and 2,000 units respectively. In the next year, the number of sales of product ordered Mega X and S are 13,000, 5,000, and 4,000 units. Then, in the last year of 2022, the number of sales of product ordered Mega X and C are 6,000, 10,000, and 3,000 units respectively. The total profit gain for 3-year period were 800,000, 900,000, and 85,000 respectively. Find the profit margin in RM for each product ordered Megas and S product. Okay, we now show the calculation. Okay, for solution, let ordered be X, Mega X be Y, and S product be Z. So from here, we form the linear equation with 9,000x, 10,000y, 2,000z equals to 800,000 sales. Then in the second equation, also same lah. According to 2021 year is 13,000, 5,000, 4,000 become 900,000. And 6,000, 10,000, 3,000, 850,000. Then for this question, we are going to use grammar rule to solve this question. Okay, the first one is determinant. We will find determinant. So the first determinant is negative 175. Then the x determinant is, by using grammar rules formula, we take the constant and replace it at the x, which means the first line. So the answer we get is negative 3,500. Then for determinant y is negative 7,000. Then determinant z is negative 19,250. In order to find the x product, we use determinant x divided by determinant. So it's negative 3,050 divided by 175 equals to 20. So for the y product is determinant y divided by determinant. Negative 7,000 divide negative 175. We get 40. And for the z product is, we take determinant z divide with determinant. Determinant z is 19,250 divided with negative 175. Then we will get 110. So these are the respective the profit margin for this product. So that's it for question 1.
For question 2, I will read out the question. A coffee manufacturer and coffee shop corporation has a taxable income of 512,000 ringgit Malaysia. At the income level, the income tax rate are 17%. The sales tax rate is 10% and the service tax rate is 6%. If the tax rate is applied to the total taxable income, the resulting tax liability for the company would be 33% of taxable income. However, it is customary to deduct tax paid to one agency before computing tax for the other agency. Assume that the income tax are based on the income then remain after the sales and service tax are deducted, and that sales and service tax are computed similarly manner. What is the tax liability of the corporation as a percentage of taxable income if these deductions are taken into consideration? So for the solution, we are using the Gauss-Jordan elimination method. So we let x equal to income tax and y equal to sales tax, z equal to service tax. Since they say income tax are based on the income that remain after the sales and service tax are deducted, and then sales and service tax are computed similarly manner. So we can consider that x plus 0.917y plus 0.17x equals to 17% times 512,000, and so on at the sales tax. 0.1x plus y plus 0.1x equals to 0.1 times the 512,000, and so on with the service tax. It is same with the sales tax, and then the equation is 0.06x plus 0.06y plus z equals to 0.06 times 512,000. So that we will form the equation below, and then we start compute. So for the first one, the round 2 negative 0 is negative to 0.1 times R1, and R3 is negative with 0.06 R1, and then we will form new R2 and new R3. After the forming of new R2 and new R3, the R2 is divided with 0.983 and then become a new R2. And then the R3 is negative with 0.0498 R2 equals to new R3. And then we will form the final matrix. So the 616 over 625 Z equals to 23,344.70 cents. So that Z equals to 23,685.78 cents. And we compress the Z into the Y plus 83 over 983 Z. So that the Y, and then we calculate the equation, then we will get the Y equals to RM 40,031.1 cents. And then we take the calculated Z and calculated Y and then put into the first equation to get the X. After calculate the equation, we will get the X equals to RM 76,208 ringgit Malaysia, and then with 32 cents. So total equals to X plus Y plus Z equals to 139,925.8 cents. And then the total rate is the total divided with the 512,000 and then times with 100% equals to 27.33%. Okay, that is all from the question 2. We consider to question 3.
Okay, next will be question 3. I will read out the question first. Netco manufactured 2 products, Ondit and Mega X. No inventories are held. The budgeted sales price for the product Ondit and Mega X are RM72 and 55 respectively. The company has a fixed cost of 10,000 ringgit per quarter with direct material cost RM6 and RM9 for the product. Ondit and Mega X direct materials are known to be in short supply, with 900 ringgit worth being available to purchase each week. There are also overhead costs RM5 and RM6 for the product Ondit and Mega X respectively. Well, there are currently 12 people working in the machining department, paid RM 10 ringgit per hours, and 2 finishing department paid RM 12 per hour in Netco. For the product Ondens and Mega X, the machining department needs 4 hours and 2 hours to complete these two products respectively, while the finishing department needs 30 minutes to complete these two products respectively. Due to the specialized nature of work involved in each area, skills are not transferable between the department. All employees work a 48 hours week. Assume that there are 12 weeks in the 3-month period. Calculate the optimum production plan per week if the company aims to maximize the profit and indicate the estimated profit for 3-month period. So next will be the solution. For question 3, we use linear programming method. So this is the table where we sort out from the question 3. Ondred and Mega X, the selling price will be 72 and for Ondred and Mega X 55. Less variable cost will be, the first one will be direct material, which is RM6 and RM9. Machining cost is like 4 times with 10 ringgit per hour, so will be 40, and 2 hours times with 10 ringgit per hour will be 20, and finishing cost is 6 and 6 because half 1 hour it's like half of the hour, so 30 minutes, so will be 6 and another 6 for Mega X, and overhead cost is 5 ringgit and 6 ringgit, so the total for n 100 will be 15 and Mega X is 14. So the P is for selling price. So 15x plus 14y, then 6x plus 9y less than 900 will be the substitution for number 1. 4x plus 2y less than 576 will be number 2. 0.5x plus 0.5y less than 96 will be number 3. X, y greater than 0. So the solution is for plotting the graph. So when x equals to 0 for substitution number 1, 9y equals to 900. So y will be 100. For number 2, 2y equals to 576, y equals to 288, and for 3, 0.5y equals 96, y equals to 192. So for y-axis, when y equals to 0, for substitution number 1, 6x equals to 900, x equals to 150. For substitution number 2, 4x equals to 576, x equals to 144. For substitution number 3, 0.5 equals to 96, x equals to 192. So another step will be 0 and 100. Price equals to 15x plus y, 14y. So 15 times with 0 plus 14 times with 100. So we'll get RM 1400. Number 2 will be 144 and 0. So the price will be 15. The same goes as the question solution number 1. 144 need to times with 15 and 4 plus 14 with 0. The answer will be RM 2160. Number 3 is 141 and 6. So 15 times with 141 plus 14 times with 6, the answer will be RM 2199. Therefore, the 0.1416 gives the most profit RM 2199. Therefore, the optimum production plan per week is to manufacture 141 units for product 100 and 6 units for product Mega X. The estimated profit for 3-month period will be 2,199 times with 12 minus 10,000. So the final answer will be RM 16,388. So this is the graph for question number 3. You can proceed with the question number 4.
The question for is about a grocery store sells 3 types of cooking oil: Red Eagle cooking oil 1 kg for 8 ringgit, Night cooking oil 1 kg for 11 ringgit, Natural cooking oil 1 kg for 16 ringgit. On the particular day, 130 kg was sold 1,396 ringgit. 2 times as many kg of Red Eagle cooking oil as natural cooking oil. How many 1 kg bottle were sold for each type of cooking oil on that day? So we move to the solution. So let S become the Red Eagle cooking oil, Y become the knife cooking oil, and Z for the natural cooking oil. So based on the question, we can form 3 linear equations. The first equation we can classify from the kilogram. Beside that, the second equation we can find from the prices, and the last s equal to 2z we can form from the question which is about the 2 times as many kg of red eagle cooking oil as natural cooking oil. So the Gaussian-Jordan elimination is used in this question, which it involves the argument matrix to reduce to the row echelon form by using the elementary row operation. So lastly, we will get the z equal to 34, and we sub the z into the equation of y plus 3z equal to 130, and it will give the y value become 28, and we sub both of the z value and y value, which is 34 and 28 respectively, into the equation s plus y plus z equal to 130, and we will get the s value, which is 68. So this is the end of the question 4.
So let's move on to part B. In part B, we have selected a question, which is question 1, and did the pseudocode and also the coding. So for the pseudocode based on question 1, we will start first and then display the instruction set for users. For I less than or equal to 3, this is where the user will input values of x1, y1, z1, c1, and also x2, y2, z2, c2. Same goes with x3, y3, z3, and c3. And we will end the for loop. For j less than or equal to 3, if read input y is positive and z is positive, the equation will show x plus y plus z. Else if read input y is negative and z is negative, the equation will show x minus y minus z. Else if read input y is negative, the equation will show x minus y plus z. Else if read input z is negative, the equation will show x plus y minus z, and this is n for if and n for the for loop. So next, it will display 3 linear equation according to user input. So for determinant, it is x1 times in bracket y2 times z3 minus y3 times z2 close the brackets minus y1 times in bracket x2 times z3 close bracket minus x3 times z2 close bracket plus with z1 times in bracket x2 times y3 minus x3 times y2 in bracket. For determinant x, which is equals to c1 times with y2 and times z3 in bracket minus y3 times z2 minus y1 in bracket c2 times z3 minus c3 times z2 plus z1 times c2 times y3 and minus c3 times y2. For determinant y, it will be x1 times c2 times z3 minus c3 times z2 minus c1 times x2 times z3 minus x3 times z2 plus z1 times x2 times c3 minus x3 times c2. And lastly, for determinant z, the equation will be x1 times in bracket y2 times c3 minus in bracket y3 times c2 minus y1 times in bracket x2 times c3 minus x3 times c2 in bracket plus c1 times x2 times y3 in bracket minus x3 times y2. So it will display the determinants of d, dx, dy, and dz. Compute Cramer's rule with x equals to determinant x times divided by determinant. Compute Cramer's rule with y equals to determinant y divided by determinant. Compute Cramer's rule with z equals to determinant z divided by determinant. It will display the results of x, y, z, and end.
Okay, so I will continue for the coding part. So first of all, the header file, we use the include stdio, which represent the standard input output and the main function. So first, we declare a total of 11 variables, which is d, dx, dy, dz, x, y, z with lowercase c and also uppercase x, y, z. From the line 8 to the line 10, we just to welcome the user to use this Cramer's rules calculator and let the user to know the concept that we use, which is xn plus yn plus zn equals to cn. C will be 1, 2, 3 until infinity. So for the first one, as we follow from the pseudocode, we use for loop, which is I equals to 1 and I will small n equals to 3. This is for the user to input their number. After that, they will get their equation that they input their number just now from the line 25. After that, from the line 27 is to let the user to show the equation. Okay, so next. Okay, so after showing the equation, we form the formula for the determinant x, determinant y, and determinant z. Okay, so after forming the equation, the formula, we will print out all the determinant, the 4 determinant, and compute the Cramer's rule for x, y, z, and then print out the result. That's all for the coding. Next. Okay, so as you can see here, for the output of program, first we will enter x1, x2, xz, y1, y2, yz, z1, z2, z3, and following by the c1, c2, and c3. And you can see it will show the equation and determinant, and finally show the result, which is same as the question 1 where we do manually. That's for the coding.
So we have reached our conclusion. Based on the project our group has done, we can learn that there are many problems of real applications in the business trigger. From this project, we have learned to solve the problems using algebra, hence increasing our knowledge in algebra. This project has increased our skills in problem solving using different methods in metrics, for example, by using Gauss-Jordan elimination method. On the other hand, we have also increased our skills in developing C program related to the problem we chose. Lastly, we hope that our project can help the students of UTHM to increase their knowledge regarding problem solving using the methods in algebra. Thank you.